Exploring Schrödinger's concept of a universal mind. Brief introduction to Erwin Schrödinger and his contributions to quantum mechanics. Erwin Schrödinger, 1887–1961, was an Austrian physicist who made significant contributions to the field of quantum mechanics. Born in Vienna, Schrödinger studied theoretical physics and became known for his pioneering work in wave mechanics. In 1926, Schrödinger formulated what is now known as the Schrödinger equation, a fundamental equation in quantum mechanics. This equation describes how the wave function of a physical system evolves over time, providing a mathematical framework to predict the behavior of quantum particles. Schrödinger's wave mechanics was revolutionary and offered a powerful alternative to other formulations of quantum mechanics, such as matrix mechanics developed by Werner Heisenberg. Schrödinger's work helped unify and clarify various aspects of quantum theory, and his equation remains a cornerstone of modern quantum physics. His contributions earned him the Nobel Prize in Physics in 1933, which he shared with Paul Dirac. Beyond his scientific achievements, Schrödinger also explored philosophical and metaphysical questions, particularly concerning the nature of consciousness and its relationship to the physical world. His interest in Eastern philosophy, particularly Vedanta, influenced his views on the interconnectedness of the universe and the concept of a universal mind. Overall, Erwin Schrödinger is celebrated for his profound impact on quantum mechanics, and his legacy extends not only to the realm of physics but also to the broader philosophical discussions about the nature of reality and consciousness. Preview of Schrödinger's philosophical ideas regarding the mind and the universe. Erwin Schrödinger's philosophical ideas regarding the mind and the universe were deeply influenced by his exploration of Eastern philosophy, particularly Vedanta, and his foundational work in quantum mechanics. He proposed a perspective that challenged conventional notions of reality and consciousness. At the core of Schrödinger's philosophy was the belief in the indivisibility of the universe. He posited that separations into individual objects and minds are mere illusions, and that everything is interconnected at a fundamental level. This concept echoed the Vedantic notion of Brahman, an ultimate reality that underlies all existence. Furthermore, Schrödinger suggested that individual minds are manifestations of a larger, universal consciousness. In this view, the boundaries between individual consciousnesses blur, implying a collective, unified field of awareness that transcends individual identities. These ideas proposed by Schrödinger provoked profound questions about the nature of reality and the mind. They challenged the prevailing reductionist views in science, which sought to explain everything in terms of isolated, individual entities. Instead, Schrödinger's philosophy pointed towards a holistic understanding of the universe, where consciousness plays a central role. It's important to note that Schrödinger himself acknowledged the speculative nature of these ideas. They represented a departure from mainstream scientific thought and remain largely philosophical in nature. Nevertheless, they continue to stimulate discussions about the nature of consciousness, the fabric of reality, and the potential intersections between science and spirituality. Section 1: Schrödinger's encounter with Eastern philosophy. Overview of Schrödinger's interest in Vedanta and its influence on his worldview. Erwin Schrödinger's interest in Vedanta, a school of Hindu philosophy, played a significant role in shaping his philosophical outlook and worldview. This fascination emerged during a period of intellectual exploration in the early 20th century, when Eastern philosophy was gaining attention in Western academic circles. Schrödinger was drawn to Vedanta's profound contemplation of the nature of reality, consciousness, and the interconnection of all things. Vedanta posits that there is an ultimate, unchanging reality called Brahman, which underlies and unifies all phenomena in the universe. This idea deeply resonated with Schrödinger's own philosophical inquiries. One of the key Vedantic concepts that influenced Schrödinger was the notion of Advaita, or non-dualism. Advaita Vedanta asserts that there is an underlying unity in the diversity of the universe. This concept was remarkably compatible with Schrödinger's own intuitions about the interconnectedness of all phenomena, which he later applied to his scientific work in quantum mechanics. Furthermore, Schrodinger's studies of Vedanta encouraged him to question the conventional Western view of the mind as something isolated from the external world. In Vedantic philosophy, the mind is seen as a manifestation of the universal consciousness, blurring the distinction between individual and cosmic awareness. Schrödinger found resonance in this idea, as it aligned with his belief in the fundamental unity of all existence. Schrödinger's engagement with Vedanta was not merely an intellectual exercise, but rather a deeply personal exploration. He incorporated these philosophical insights into his broader understanding of reality, which influenced both his scientific work and his reflections on the nature of consciousness. It is worth noting that Schrödinger was aware of the distinct realms of science and philosophy. While he acknowledged the speculative nature of his Vedantic-inspired ideas, he believed that they provided a valuable perspective on the fundamental nature of reality and consciousness. In summary, Erwin Schrödinger's interest in Vedanta profoundly influenced his philosophical outlook. His engagement with Eastern philosophy, particularly Vedanta, provided him with a unique lens through which he contemplated the interconnectedness of the universe and the nature of consciousness, contributing to his broader intellectual legacy. Explanation of key Vedantic concepts like Brahman and the interconnectedness of all things. In Vedanta, a school of Hindu philosophy, several key concepts form the foundation of its metaphysical understanding of reality. Two fundamental notions are Brahman and the interconnectedness of all things. 1. Brahman. Definition: Brahman is the ultimate, unchanging reality or absolute. It is considered to be formless, infinite, and beyond all attributes. Brahman is often described as the source and essence of the universe, transcending space, time, and causality. Impersonal and non-dual, Brahman is neither a personal deity nor a separate entity. It is impersonal, meaning it doesn't have personal attributes or characteristics. Moreover, Brahman is non-dual, Advaita, implying that there is no fundamental distinction between the individual self, Atman, and Brahman. Immanent and transcendent. While Brahman is transcendent, existing beyond the manifest world, it is also immanent, permeating every aspect of creation. This means that everything in the universe, from the smallest particle to the largest galaxy, is an expression or manifestation of Brahman. Source of all phenomena. According to Vedanta, all phenomena emerge from Brahman and ultimately return to it. This includes the physical world, living beings, thoughts, emotions, and even the laws governing the universe. 2. Interconnectedness of all things. Unity in diversity. Vedanta emphasizes the essential unity that underlies the diversity of the world. Despite the apparent multiplicity of objects and beings, there is an underlying oneness that binds everything together. Web of interdependence. Vedanta asserts that the existence of any individual entity is intimately connected to the existence of all other entities. In this view, no object or being can exist in isolation, everything is interdependent. Illusory nature of separateness. While individuality and distinct forms are apparent in the world, Vedanta suggests that these separations are illusory. They are like ripples on the surface of a vast, undivided ocean, Brahman. Reflection in the microcosm. Just as the macrocosm, universe, is interconnected, the microcosm, individual beings, also reflect this interdependence. Each individual's consciousness is considered a microcosmic reflection of the universal consciousness, Brahman. Ethical implications. Recognizing the interconnectedness of all beings leads to ethical considerations. Actions that harm others are seen as ultimately self-destructive, as they disrupt the harmony of the interconnected whole. Together, these Vedantic concepts provide a comprehensive framework for understanding the nature of reality, consciousness, and the relationship between the individual self, Atman, and the ultimate reality, Brahman. They influenced not only philosophical and spiritual traditions but also had an impact on thinkers like Erwin Schrödinger, who integrated these ideas into his own philosophical musings and scientific work. Section 2. Quantum Mechanics and the Nature of Reality. Brief overview of quantum mechanics and its implications for our understanding of reality. Quantum mechanics is a branch of physics that deals with the behavior of very small particles, such as atoms, electrons, and photons. It was developed in the early 20th century to explain the behavior of these particles, which classical physics could not account for. Here's a brief overview of quantum mechanics and its implications for our understanding of reality. 1. Wave-particle duality. One of the key features of quantum mechanics is the concept of wave-particle duality. It suggests that particles, such as electrons and photons, can exhibit both wave-like and particle-like properties. This means they can behave as if they were waves or as discrete particles, depending on the experimental setup. 2. Uncertainty principle. Proposed by Werner Heisenberg, the uncertainty principle states that it is impossible to simultaneously know both the precise position and momentum of a particle. This principle introduces a fundamental limit to the precision with which we can measure certain properties of particles. 3. Quantization of energy. Quantum mechanics introduced the idea that energy is quantized, meaning it can only exist in discrete, distinct levels. This explains phenomena like atomic and molecular spectra, where only specific energy levels are allowed. 4. Superposition and entanglement. Quantum mechanics allows for the concept of superposition, where particles can exist in multiple states at once. Entanglement, another quantum phenomenon, describes the correlation between the properties of particles even when they are far apart. Changes to one particle instantaneously affect the other, regardless of the distance separating them. 5. Probabilistic nature. Quantum mechanics operates in a probabilistic framework. Instead of predicting exact outcomes, it provides probabilities of different outcomes. This challenges the deterministic view of classical physics and introduces an inherent element of unpredictability. 6. Collapse of the wave function. When a measurement is made on a quantum system, the wave function, which describes the probability distribution of possible states, collapses to a specific outcome. This is a fundamental aspect of how we interact with the quantum world. 7. Quantum computing and information. Quantum mechanics has given rise to the field of quantum computing, which leverages the principles of superposition and entanglement to perform certain types of calculations much faster than classical computers. The implications of quantum mechanics for our understanding of reality are profound. They challenge our intuitive notions about how the world works at the smallest scales. The theory has been experimentally verified countless times, and its applications extend from the behavior of subatomic particles to the functioning of semiconductors in modern electronics. Quantum mechanics has revolutionized our understanding of the physical world and has led to numerous technological advancements. Schrodinger's development of the Schrödinger equation and its role in describing quantum systems. Erwin Schrödinger's development of the Schrödinger equation was a pivotal moment in the history of quantum mechanics. This equation is a cornerstone of the theory and plays a central role in describing the behavior of quantum systems. 1. Background: wave mechanics versus matrix mechanics. In the early 1920s, quantum mechanics was in its infancy, and two competing formalisms were being developed: wave mechanics and matrix mechanics. Schrödinger, influenced by his background in theoretical physics and a desire for a more intuitive approach, set out to create a wave-based formulation of quantum mechanics. 2. The Schrödinger equation. In 1926, Schrödinger successfully formulated the Schrödinger equation, which is a partial differential equation that describes how the wave function of a physical system evolves over time. 3. Interpretation of the Schrödinger equation. The equation is foundational because it provides a mathematical framework to predict the behavior of quantum particles. It determines how the probability amplitudes, given by the wave function, evolve over time in response to the system's energy and potential. The solutions to the Schrödinger equation yield the allowed energy levels, quantization, and the corresponding wave functions for a given system. 4. Physical significance. The square magnitude of the wave function psi square 2 gives the probability density of finding a particle at a particular location. This means that the Schrödinger equation provides a method for calculating probabilities associated with different outcomes of measurements. The Schrödinger equation has been successfully applied to a wide range of physical systems, from electrons in atoms to the behavior of molecules in larger quantum systems. 5. Importance and legacy. Schrödinger's wave mechanics, based on the Schrödinger equation, became the dominant formulation of quantum mechanics due to its simplicity and intuitive appeal. It unified and generalized many of the results obtained from matrix mechanics. The equation's predictive power revolutionized our understanding of the behavior of particles at the quantum level and laid the groundwork for numerous technological advancements. In summary, the Schrödinger equation, formulated by Erwin Schrödinger, is a fundamental equation in quantum mechanics that describes how the wave function of a physical system evolves over time. It plays a central role in predicting the behavior of quantum particles and has had a profound impact on our understanding of the subatomic world. Section 3. The illusion of separateness. Schrödinger's belief that the universe is an undivided whole. Erwin Schrödinger's belief in the unity or undivided nature of the universe stems from his philosophical and metaphysical explorations, influenced in part by Eastern philosophies like Vedanta. This perspective challenges the conventional, reductionist view of reality prevalent in classical physics. 1. Holistic perspective. Schrödinger proposed that the universe should be viewed as an indivisible, interconnected whole. This means that all phenomena, no matter how seemingly disparate, are fundamentally linked. He argued that trying to understand reality by isolating individual objects or particles leads to an incomplete and misleading picture of the true nature of the universe. 2. Illusion of separateness. According to Schrödinger, the apparent distinctions between objects and beings in the world are illusory. These separations are mere constructs of our limited human perception and do not reflect the deeper, underlying reality. This perspective aligns with certain interpretations of Eastern philosophies, which suggest that the perceived multiplicity of the world is a superficial veil over a deeper, unifying reality. 3. Wave function and quantum superposition. Schrödinger's formulation of quantum mechanics through the Schrödinger equation also supports this view. The wave function, which describes the probability distribution of a particle's properties, often exhibits states of superposition, where the particle exists in multiple states simultaneously. This implies that particles do not have definite properties until observed. This supports the idea of an interconnected reality where the state of one particle can instantaneously influence the state of another, regardless of distance. 4. Influence on quantum entanglement. Schrödinger's belief in the undivided nature of the universe is reflected in the phenomenon of quantum entanglement. Entangled particles maintain a deep, instantaneous connection, even when separated by vast distances. This challenged the classical notion of locality, where effects can only propagate at or below the speed of light. Instead, entanglement suggests an immediate and non-local connection between particles. 5. Ethical and philosophical implications. Schrödinger's perspective had broader implications for ethics and philosophy. Recognizing the interdependence of all things, he argued, should lead to a more compassionate and ethical approach to living and interacting in the world. Schrödinger's belief in the undivided whole of the universe represents a departure from the traditional scientific reductionism, suggesting a more holistic and integrated understanding of reality. While his ideas are philosophical and speculative in nature, they have had a lasting influence on the way we think about the nature of the universe and our place within it. Exploration of how separations into individual objects and minds are considered illusory in Schrödinger's perspective. In Erwin Schrödinger's perspective, separations into individual objects and minds are considered illusory, reflecting his philosophical views influenced by Eastern thought, particularly Vedanta. He believed that the conventional division of reality into discrete, separate entities is misleading and does not reflect the true nature of the universe. Here's an exploration of how Schrödinger viewed these separations as illusory. 1. The illusion of objectivity. Schrödinger argued that our perception of the world as a collection of distinct, independent objects is an illusion created by our sensory and cognitive processes. He believed that beneath the apparent multiplicity of objects lies an underlying unity, where boundaries between objects blur. 2. Interconnectedness. Central to Schrödinger's perspective was the idea of interconnectedness. He saw all things in the universe as interconnected and interdependent. This interconnectedness implies that there are no isolated entities. Instead, everything is part of a larger, unified whole. 3. The mind-body connection. Schrödinger extended this notion of interconnectedness to the relationship between the mind and the body. He believed that the mind and the body are not separate entities but are deeply entwined. In his view, the separation between mental and physical realms is artificial and does not accurately capture the holistic nature of consciousness. 4. Vedantic influence. Schrödinger's ideas were heavily influenced by Vedanta, which emphasizes non-dualism, Advaita. According to this philosophy, there is no fundamental distinction between individual selves, Atman, and the ultimate reality, Brahman. In the Advaita Vedanta view, the separation between the individual self and the universe is illusory, and true understanding comes from recognizing the inherent unity. 5. Quantum mechanics and wave functions. Schrödinger's work in quantum mechanics contributed to his perspective. In quantum mechanics, particles are described by wave functions, which can exist in superpositions of multiple states simultaneously. This superposition suggests that particles do not have well-defined properties until measured. In a sense, the boundaries between particle states are blurred until observation collapses the wave function into a particular outcome. 6. Ethical and spiritual implications. Schrödinger believed that recognizing the illusory nature of separateness should lead to a more compassionate and ethical way of living. In his view, an understanding of interconnectedness fosters a sense of responsibility for the well-being of others, as harm to others is ultimately harm to oneself. In summary, Schrödinger's perspective on the illusory nature of separations into individual objects and minds was deeply rooted in his philosophical and metaphysical explorations. He saw these divisions as misleading constructs that obscure the fundamental interconnectedness and unity of the universe, a perspective influenced by Eastern philosophies like Vedanta and reflected in his work in quantum mechanics. Section 4. Individual minds as manifestations. Elaboration on Schrödinger's notion that individual minds are manifestations of a larger universal consciousness. Erwin Schrödinger's notion that individual minds are manifestations of a larger universal consciousness reflects his philosophical explorations, particularly influenced by Eastern philosophies like Vedanta. This concept proposes a profound interconnectedness between individual consciousnesses and a universal, all-encompassing awareness. Here's an elaboration on Schrödinger's perspective. 1. The universal consciousness, Brahman. Schrödinger drew from Vedantic philosophy, which posits the existence of an ultimate reality known as Brahman. Brahman is often described as an infinite, unchanging consciousness that underlies and unifies all existence. According to Vedanta, Brahman is the source of all individual consciousnesses and is omnipresent, pervading every aspect of the universe. 2. Individual minds as expressions. In Schrödinger's view, individual minds are not separate, isolated entities, but rather expressions or manifestations of this larger, universal consciousness. Each individual's consciousness is considered a microcosmic reflection of the universal consciousness, Brahman, akin to ripples on the surface of a vast, undivided ocean. 3. The illusion of individuality. Schrödinger believed that the sense of individual identity and separateness is a product of our limited perception and cognitive processes. He considered this perception to be illusory. From his perspective, the true nature of consciousness transcends individuality and is part of a unified, collective awareness. 4. Implications for identity and existence. This perspective raises profound questions about the nature of personal identity and existence. If individual minds are ultimately expressions of a universal consciousness, then notions of distinct personal identities become relative and secondary. It implies that the boundaries between individuals are illusory, and the true essence of consciousness is a shared, universal phenomenon. 5. unity and interconnectedness. Schrodinger's concept aligns with the Vedantic principle of Advaita, or non-duality, which asserts that there is no fundamental separation between individual selves, Atman, and the ultimate reality, Brahman. This underscores the inherent unity and interconnectedness of all beings, emphasizing that the perceived multiplicity of consciousnesses is a surface-level phenomenon. 6. Ethical and spiritual implications. Recognizing the interconnectedness of individual minds and their origin in a universal consciousness has ethical and spiritual implications. It fosters a sense of empathy, compassion, and responsibility towards others, as harming another being would ultimately be a reflection of harming oneself. In summary, Schrödinger's notion that individual minds are manifestations of a larger universal consciousness reflects his philosophical and metaphysical inquiries influenced by Vedanta. It challenges conventional notions of personal identity and highlights the deep interconnectedness of all conscious beings in the fabric of the universe. While speculative, this perspective offers a unique and profound way of contemplating the nature of consciousness and existence. Discussion on the implications of this idea for our understanding of consciousness. Erwin Schrödinger's idea that individual minds are manifestations of a larger universal consciousness has profound implications for our understanding of consciousness. It challenges traditional perspectives on the nature of consciousness and invites a more holistic and interconnected view. Here's a discussion on the implications of this idea. 1. Non-dualistic nature of consciousness. Schrödinger's concept aligns with the non-dualistic philosophy found in Eastern traditions like Vedanta. It suggests that there is no fundamental distinction between individual consciousnesses and the universal consciousness, Brahman. This challenges dualistic views that posit a strict separation between mind and world, or between individual consciousness and an external reality. 2. Unity of subject and object. This perspective blurs the boundary between subject and object. In traditional Western philosophy, there is often a clear distinction between the observer, subject, and the observed, object. However, Schrödinger's idea suggests a fundamental unity between the observer and the observed. It implies that consciousness is not something confined to an individual mind, but rather a fundamental aspect of the universe itself. 3. Collective consciousness. If individual minds are considered manifestations of a larger universal consciousness, it suggests that there is a collective, shared aspect to consciousness that transcends individual identities. This raises questions about the nature of shared experiences, empathy, and the potential for interconnected forms of awareness. 4. Implications for identity and self. The idea challenges conventional notions of personal identity. If individual minds are expressions of a universal consciousness, then personal identity becomes a relative and secondary aspect of consciousness. It prompts a re-evaluation of the nature of self and suggests that the boundaries defining who we are may be more fluid and interconnected than traditionally assumed. 5. Ethical considerations. Recognizing the interconnectedness of individual minds in a universal consciousness has ethical implications. It promotes a sense of empathy, compassion, and responsibility towards others. Harming others would be seen as ultimately harming oneself, as they are considered expressions of the same universal consciousness. 6. Implications for neuroscience and psychology. This perspective challenges materialistic views of consciousness that seek to locate it solely in the physical brain. Instead, it opens the door to considering consciousness as a more fundamental aspect of reality. It prompts a re-evaluation of how we study and understand consciousness within the fields of neuroscience and psychology. In summary, Schrödinger's idea that individual minds are manifestations of a larger universal consciousness invites a profound re-examination of our understanding of consciousness. It challenges dualistic and materialistic views, emphasizing the interconnectedness and unity of all conscious beings. While speculative, this perspective offers a unique and thought-provoking framework for contemplating the nature of consciousness and its relationship to the universe.